Ladies and gentlemen, welcome to our seminar with the 8th number of ESTU Sustainable Campus Commission. We are going to be together. I want to thank everyone for joining our seminar, and as I see the Rector University of our university, Professor Dr. Tuncay, the role is also in our meeting. If she's here, I want to invite her to have her welcome message for our participants. Yes, please.
Thank you, Dr. Jawad. Good afternoon to all. I'm really sorry for my delay. I changed my place. I was in my office. Now I moved to home. Dear all, welcome to 18th Sustainable Ecocampus Seminar, titled with the Sustainable and Resilient Building Design. And first of all, I salute our panelists, dear distinguished panelists, and all participants on behalf of myself and also our university. I also special thank to our panelists for their valuable contribution and participation. And lastly, I wish this meeting to be successful and productive as in the previous ones. Thank you very much for this meeting.
Thank you very much, Professor Dr. Tuncay, and thanks again, everyone. I want to invite Vice Chairman of ESTU Sustainable Campus Commission, Professor Dr. Untitled Chapter, for having his welcome message. Yes, please.
Thank you, Dr. Jawad. Dear Rector, dear moderators, Dr. Said Ahmet Reza and Dr. Jawad, dear speakers, Dr. Nazan, Dr. Ali, Dr. Saberi, and Ms. Yasemin. Ladies and gentlemen, good morning, good evening to all participants. First, I want to special thanks Professor Alper Çabuk for his efforts in this series. It's my pleasure to welcome all the participants today for Sustainable Ecocampus Conference Series. This is the 8th. This title is Sustainable and Resilient Building Design. I am a Vice Chairman of the Sustainable Ecocampus Commission. Besides basic knowledge improvements for our students, we support all activities related to sustainability in our university. So our first aim is to make the university more sustainable. As I talked on my previous speech, I mentioned our purposes. We measure our purposes and our sustainability potential with the green metric scale. This green metric is a sample university ranking system. Eskişehir Technical University applied for the green metric ranking for the first time in 2019. 2019 ranking was 617. In 2020, our ranking is 525. The ranking is indicated that university has made significant progress in line with our sustainability goals and plans. We hope and act to improve our ranking according to our activities. This online seminar series is a part of it. I'm also proud to announce that the current conference is being conducted along with the cooperation of the Eskişehir Technical University and Chamber of Architects. I would like to thank you for your participants. I hope this seminar will touch your future. Thank you.
Thank you so much.
Thank you very much, Professor Dr. Untitled Chapter. According to our program and like our previous seminars, we are going to have our speeches from speakers, and then at the end of our meetings, we will have ask and answer part. I want to ask Dr. Kanifar to introduce our first speaker. Yes, please.
Thank you so much, Dr. Jawad. Before introducing the first speaker, Dr. Nazan Kılıç, I want to say a warm welcome to Professor Tuncay, respectful rector of the Eskişehir Technical University, and also Dr. Önder Altuntaş for his support of our webinar, which is really highly appreciated. And then the first speaker will be Dr. Nazan Kilic. She holds PhD in civil engineering from Middle East Technical University, Turkey. She works in Disaster and Emergency Management Authority AFAD in Turkey, and as one of the high-ranking civil engineers in earthquake development, and her studies focus mainly on seismic hazard assessment. Her presentation is Earthquake Hazard Map of Turkey and Turkish Building Earthquake Code. The session is yours, Dr. Nazan. Please present your speech.
Thank you. Share screen yaptım, olmuyor. Nerede Tuğba'cığım?
Can I ask İhsan Bey to open the share screen, please? Yes, thank you.
Okay, thank you. Good afternoon, everyone. First of all, I would like to thank the distinguished moderators of this webinar and others who played the role in the organization of this valuable webinar. And I would also thank distinguished speakers and you for the attendance. As the title of my presentation implies, today I'll talk about the earthquake hazard map of Turkey and Turkish Building Earthquake Code. But before, I would like to give a brief information on disasters in our country and seismicity of our country. Our country is affected by many man-made and natural disasters. Among them, especially earthquakes cause great losses in our country. Landslides, floods, fires and avalanches are other natural disasters that occur in our country. Due to its tectonic location, our country has been exposed to destructive earthquakes since historical period. And the map in this slide shows the distribution of earthquakes that occurred in our country and its near surrounding since 1900. Among this earthquake, 250 earthquakes caused damage and 218 earthquakes have magnitude equal to or greater than 6. The earthquake activity in our country and its surrounding has been observed by AFAD with more than 1,100 seismic stations, and the map shown in this slide shows the distribution of these seismic stations. If you look at the historical development of official earthquake zoning or hazard maps of our country, the origins of the first official map dates back to 1939 Great Erzincan earthquake. This earthquake was followed by a series of large earthquakes on North Anatolian Fault, and in 1944, the law on measures to be taken before and after earthquakes was enacted. In accordance with one of the provisions in this law, the first earthquake zoning map of our country was prepared and published in 1945. This due to increased information on the seismotectonics of our country, advances in engineering seismology and developments in the world, this map was revised and published several times, and the last one, that is the earthquake hazard map of Turkey, was published in Official Gazette in 2018, and it has been in force since the beginning of 2019. The new earthquake hazard map of Turkey is one of the objectives in our National Earthquake Strategy and Action Plan, abbreviated as UTSEP 2023. This strategy and action plan can be defined as our national roadmap for earthquake mitigation. The principal objective of the plan is to constitute new earthquake resistant, safe, well-prepared and sustainable settlement, and so to prevent or mitigate the physical, economic, social, environmental and political harms and losses that may be caused by earthquakes. There are 7 targets, 29 strategies and 87 actions in the plan. They are presented under 3 thematic groups. They are learning about earthquakes, earthquake safe settlement and construction, and coping with the consequences of earthquakes. Although target strategies and actions are given under 3 thematic groups, they are mainly interconnected to each other. In accordance with its general scope, risk reduction activities are dominant in the UTSEP 2023, but there are some actions devoted for the development of emergency management and post-disaster recovery activities. So UTSEP 2023 contributes the mitigation, preparedness, response, and recovery phases of the disaster management cycle. Earthquake hazard analysis and revision of hazard maps are one of the objectives in UTSEP 2023. A project was initiated in 2013 to revise the previous earthquake zoning map of Turkey. The project, the revision of Turkish seismic hazard map project, was supported by AFAD within the scope of National Earthquake Research Program. Turkish Natural Catastrophe Insurance Pool also supported the project. The project team consists of researchers from 2 public institutions, AFAD and General Directorate of Mineral Research and Exploration, and 5 universities, Boğaziçi, Middle East Technical, Çukurova, Sakarya, and Akdeniz universities. In the project, probabilistic seismic hazard analysis were performed by utilizing up-to-date seismic source models, earthquake catalogs, ground motion prediction equations, and so on. And earthquake hazard maps in terms of peak ground acceleration, peak ground velocity, and spectral accelerations at 0.2 seconds and 1 second periods are produced for different return periods that are 43, 72, 475, and 475 years return period. I should note that these maps were produced for a generic rock site condition. The new earthquake hazard map of our country is a product of this project. It shows peak ground acceleration values having 10% probability of exceedance in 50 years, which corresponds to a return period of 475 years. It does not include the hazards caused by local soil conditions like liquefactions, ground amplification, subsidence, and so on. In addition to new earthquake hazard map of Turkey, the data on peak ground acceleration, peak ground velocity, and spectral acceleration at short and 1 second periods was published in the official gazette for different accidents probabilities in 50 years. So an interactive web application was developed, the earthquake hazard, to view and query the earthquake hazard maps prepared based on this data in web environment. And this slide shows the general view of this web interface. In this web interface, there's a map window and some tools, menus, and boxes on and at the left side of this map window. Now I'm going to introduce some of them. The search box at the top left top corner of the map window enables to view an address on the map. When you type at least 3 letters of an address to this box, the application lists 10 addresses that are mostly related with this information. When you select among them, the application zoom in and show it as blue shaded area. You can also search for an address by address query menu. On this menu, you should first select province and then district and then village or neighborhood. The application lists zoom in each selection and show it as blue shaded area. You can make some changes on the map window through layer control menu. On this menu, there are 4 different tabs. First one is the hazard maps tab. On this tab, there are 16 different earthquake hazard map options in terms of 4 different ground motion parameters and 4 different return pairs that I mentioned just before. You can change or reduce the visibility of the hazard map so the base map under it becomes more visible. For this, there are 4 different visibility level options for the hazard map. You can add contours to the map by turning on the contour option. The second tab is the base map tab. On this tab, there are 4 different base map options. The third one is the other layers tab. You can add lakes, active faults, neighborhood, district, province, and street layers to the map window by this tab. The last one is the grid tab. You can add grids to hazard map by this tab. There are different grid options with different spacing in this tab. You can obtain ground motion value or the earthquake hazard of a site by get information or get information by entering coordinates tools. You can specify the site by clicking on the map by get information tool, or you can enter its coordinates on the get information by entering coordinates menu. After you specify the site, the information on the location of the site like coordinate and the ground motion value obtained from the earthquake hazard map displayed on the map window is shown on an automatically opened menu. The reporting menu was also developed to present horizontal and vertical elastic design spectrum for a site specified by the user according to Turkish Building Earthquake Code. Before mentioning the main improvements in the new map with respect to previous one, I will very briefly talk about the previous earthquake zoning map of our country. This map was prepared by Earthquake Peak Ground Acceleration Contour Map that was constructed by probabilistic seismic hazard analysis methodology for a return period of 475 years. 5 different earthquake zones are defined in this map. First degree earthquake zone is the zone with highest earthquake hazard. A practical booklet providing the earthquake zone information of each district was prepared, and in order to determine earthquake zone of a site, we use the information given in this booklet. As I mentioned before, the previous map shows the earthquake zones. The new map shows peak ground acceleration values instead of earthquake zones. So the earthquake zone concept was left by the new map. The previous map was prepared based on peak ground acceleration values for return period of 475 years. On the contrary, new maps were produced in 16 different versions, which are in terms of 4 different ground motion parameters and for 4 different return periods. Instead of booklet used with the previous map, we can obtain the earthquake hazard of a site through JS-based user-friendly interactive web tool. Our country has earthquake code since 1940s, and it has been updated and revised several times. And the last one, that is the Turkish Building Earthquake Code, was published in Official Gazette in 2018, and it has been with the new earthquake hazard map, and it has been also in force since the beginning of 2019. Let me very briefly answer the question that why is the earthquake code updated? Because in parallel with the developing needs, information and technology, the material diversity used in building construction and the building models are increased. Advances in earthquake engineering, lessons derived from past earthquakes, and the efficiencies observed in practice are the other reason for the update of the code. Development in science and practice regarding seismic assessment and strengthening of the structure is another reason. Revision and update of the earthquake code is one of the strategy in our National Earthquake Strategy and Action Plan. For this, a commission consisting of researchers with expertise in the area, as well as experts from public agencies and institutions should be formed, and the activity of the commission should be made continuous. This slide summarizes the main activities carried out during the preparation of Turkish Building Earthquake Code. An Earthquake Code Commission consisting of 15 members was set up, and the studies for the preparation of Turkish Building Earthquake Code was initiated with the commission meeting on November 2012. In this meeting, it was decided to set up sub-commissions for different parts of the code. Almost 112 experts took part in these sub-commissions and contributed to Turkish Building Earthquake Code. In addition to commission meetings and sub-commission meetings, two workshops were organized for all commission and sub-commission members to study together. Besides, 2 large-scale workshops were organized for all commission members and stakeholders to exchange their views. And then a draft code was prepared and shared with all related organizations, institutions, and universities for their comments. The comments were assessed, and the code took into its final form and published in Official Gazette. Turkish Building Earthquake Code includes minimum requirements and rules for design of new buildings, as well as seismic assessment and strengthening of the existing ones. It consists of 17 chapters shown in this slide. It's a comprehensive or extensive revision of the previous one. There are also some new chapters written in red color in this slide. one of the major improvements or change in the Turkish building earthquake code with respect to the previous one is that design supervision and control system is introduced for topics that require special expertise. If you look with respect to earthquake ground motion, new earthquake hazard map and maps and its interactive web application are referred in the Turkish building earthquake code. Consistent with the earthquake hazard maps, 4 different earthquake ground motion levels are defined in the code. Horizontal design acceleration spectrum is revised and local site effect coefficients are added to code. Vertical elastic design acceleration spectrum is also defined in the code. This slide shows the elastic design acceleration spectrum defined in the previous code and the Turkish building earthquake code. In the previous code, we used the effective ground acceleration coefficients defined according to earthquake zone and spectrum characteristic periods defined depending on local site condition to construct the design acceleration spectrum. As for the new code, Turkish building earthquake code, spectral acceleration parameters are obtained from interactive web application, and they are modified to consider local site effect. In other words, they are multiplied by local site effect coefficients to obtain design spectral acceleration parameters. Then the horizontal elastic design acceleration spectrum is constructed as illustrated in the right side of this slide. Performance-based design is highlighted for tall buildings and important buildings with high seismic hazard in the Turkish building earthquake code. If I need to describe the design procedure in the code for these types of buildings as simple as possible, the preliminary design of the building is conducted by conventional strength-based design method under standard design ground motion. Then it is assessed that whether seismic performance of this preliminary design under specified ground motion levels satisfy performance targets defined for these ground motion levels. If they are not satisfied, the design is revised. Compared with the previous code, there are new chapters on tall buildings, seismically isolated buildings, lightweight steel buildings, and wooden buildings in the Turkish building earthquake code. According to Turkish building earthquake code, structural health monitoring systems are mandatory to be installed on tall buildings. Due to public safety and economic reasons, it's important to rapidly assess the condition of tall buildings after an earthquake. Structural health monitoring systems help us to assess the current condition of the buildings in a rapid, remote, and objective way. This is the end of my presentation. I would like to thank for your kind attention.
Thank you very much, Dr. Nazan Kilic. It was great presentation. As I mentioned at the first of our seminar, we have ask and answer part at the end of our seminar. The second speaker will be Dr. Ali Asghari, but as Dr. Ecocampus told me, he had a problem with the internet connection. If Dr. Saburi, our third, yeah, am I right, Dr. Ecocampus? Dr. Saburi will be, yes. Dr. Saburi, yes. If you are here, Dr. Saburi will be thankful, and Dr. Ecocampus will introduce him to our speaker. Again, thank you very much, Dr. Nazan Kilic, for your great presentation.
Thank you very much, Dr. Nazan.
Thank you all.
Thank you very much.
Yes, Dr. Ecocampus, if you
Yes.
want, you can introduce our second speaker.
Okay,
And
just now.
then
Dr. Omid Saberi is one of the pioneer colleagues in energy and architecture. He is based on Washington, D.C., and he works across the projects within World Bank Group, including IFC investment and advisory projects. His works mainly focuses on age zero carbon certification, as well as building resilience index program. Green buildings code development is another aspect of his professional works. And in addition, he works on energy conservation at city scale. And his presentation title will be Age Green Building Certification on Race to Zero Carbon Cities. Dr. Saberi, the session is yours, please.
Good afternoon. Thank you so much for the introduction, and thank you for arranging this session. I'm very honored to be here. I'll be trying to cover my presentation with two sets of topic here, one on green and one on resilience. I'm sharing my screen here. Okay. Perfect. Okay. May I request if you're speaking to leave the phones or computers on mute. All right, so what I'm going to cover here is two pieces of work that has been done within IFC. IFC is a member of World Bank Group. One would be on green buildings and one would be on resilient buildings. And I'll try to cover the topic within the 30 minutes time limit. The work that we have been doing, international finance cooperation is part of the World Bank Group. We are the largest development bank in the world that has member countries, including Turkey is our member country, and our goal is to support solutions for private sector development. That's the key goal. Starting from the green and resilient buildings, I want to first raise the question on what is a green and resilient building? What is the definition and how we should define this? Whether this building is a green building because it's next to a forest and is covered by green, and whether it's a resilient building. And the measurement of these is a key question. Of course, there are different tools in the marketplace that try to find solutions to measure these. We have been working with different players in the world, such as US Green Building Council, BREEAM, DGNB, and in Turkey, we did work with, on the market study, we did work with the Turkey Green Building Council, and also with different projects there. But also, when you look at the different types of buildings, whether the architectural impressions that we as architects, we always love to explore different ways of designing buildings, how these designs can be measured. I have been in this business designing buildings in my previous life, and in this design, the key question for me was that how can I measure the savings and what would be the cost of these elements? Because those are the two questions that clients ask, and one needs to have answers to those questions. So that's one side of the story. And the second side of the story is these days we are facing more and more challenges of climate change. And good thing is that the Paris Agreement put in front of us a roadmap. This roadmap is published by World Green Building Council and for the building sector. And what it says that by 2030, which is 9 years from now, and the time flies these days much faster, and mainly this pandemic is making it run faster. By 2030, all new construction needs to operate at zero carbon. And by 2050, all buildings, so existing and new construction, must operate at net zero carbon. That's what we need to do in the building sector to meet the Paris Agreement requirements. But for us to get to that point, and as you can imagine, there is a huge task in front of us to get here. The new construction still struggles to meet codes and still struggles to push to become efficient. And existing buildings is also a big trouble because retrofits are expensive and it's very challenging to convince anyone to do anything on existing buildings. So what we need to do, we need to come up with certification processes, with corporate engagements, with training and education through universities like your university, and also with the government engagements. So what we have done within the ISC to enable this move is we came up with a system that is called EDGE. EDGE stands for Excellence in Design for Greater Efficiencies. It has 3 elements. There's a free application that everyone can access and calculate and measure, answering my own question of how can I calculate and measure my building. The second is what would be the standard. We came up with a simple standard of minimum 20% efficiency on energy, water, and materials. And if that minimum standard is met, then projects, they can apply for certification. And there's importance about certification, which I'll come back to it and say why certification is critical in this value chain. Because if we have these two without certification, that will not work. I'm gonna quickly demo how EDGE works and come back to this continue this presentation. So EDGE app is available to everyone. You can access at app.edgebuildings.com. You can log in with your email address. Here I'm looking at homes. There are other building types here as well. I'm looking at Turkey, Ankara, and upper middle income house. You can select the type of home. For example, it's an apartment here. I can select a single family home. I can say this apartment is 120 square meters and it has 2 bedrooms, or say it has 3 bedrooms. We can modify all these inputs. And after modifying this, we can say what kind of air conditioning or heating system is there. There is also information about climate, about the cost of electricity, cost of water, different elements here. You can modify them. After these modifications, what this tool does for you is calculates the baseline energy consumption. So in this case, the baseline energy consumption is 101 kilowatt hour per square meter, and it's broken down to hot water, electricity, for lighting and other elements. And then you can start introducing different saving elements, saying that, okay, I'm going to add insulation to my roof with a specific U value, add insulation to external walls. EDGE already has Turkey regulations built in. So when we say add, it's adding on top of what the regulations already has in Turkey. And having a specific, say, air conditioning system, and it starts calculating your savings, and let's say heat pump for hot water system. And when you reach to more than 20%, you meet the energy requirements. We can dig into this information. There's lots of information behind the scene here. For example, you can read more about insulation of the roof in the user guide. There is water efficiency measures as well. This is very important for the university students to take advantage of, because it also opens up research options here to look at the real consumptions against simulated consumption. And on the materials, we are looking at embodied energy of materials with the view that we'll move toward embodied carbon in future, but looks at what kind of different materials, how different materials impact the embodied energy of each building element. And as I said, we have a lot of papers and information published on this application that one can have access to. Once these 320 is met, then project can apply for certification. I take your attention to these elements. It talks about $38 per month would be utility saving. So this is each housing unit will save $38 per month on their utilities. This is the incremental cost, and this is the payback period in years. So it displays all this information, and also it gives you the GHG saving per housing unit, how much GHG emission will be reduced. I'll go back to the presentation here and continue. And I encourage you to have a look at this application if you find time. So what kind of buildings can be certified on the EDGE? Then practically all types of buildings. We have hospitals certified and homes certified in Turkey, and there are the different projects that are going through the process. It can be used for new construction. It can be used for existing building and refurbishment. And we are seeing, given the COVID, there's more attention to refurbishment. EDGE has 3 levels. It has the certified at 20%, EDGE Advanced, and then it has zero carbon certification. So projects, they can go through these 3 steps to get to zero carbon certification. Remember the slide I showed about the path to zero carbon? So EDGE provides that path to zero carbon certification. These are some of the projects that are certified in Turkey and other regions. You see, maybe you recognize some of these in the skylights of Turkey. We also have hospitals certified in Turkey. And the interesting thing is that it's also being used for affordable homes or low-income homes certification in other countries. One beauty of the certification is that the project, each homeowner receives 1 certificate. So the certificate is not for the entire building, but is for each housing unit. And then they can use this certificate to go to the banks and apply for a green mortgage. And our goal is that we encourage green mortgages so that banks can provide better rate to home buyers when they buy homes in efficient buildings. EDGE is approved by international green finance standards, so that makes it easy for the banks to recognize EDGE as a standard for green mortgages or green construction finance. In different countries around the world, we have banks that already recognize EDGE and provide lower interest rates to the mortgage or construction finance. These are some of the examples of the banks that already provide such incentives for buyers, home buyers. The other piece of work that we are doing is we are going country by country and trying to encourage governments or cities to come up with incentives for green buildings. These are examples that some of them are non-fiscal. So for example, in Peru, there are extra height incentives. So if you certify a building, you can get extra floor. In some countries, you have exclusion of VAT for someone that certifies buildings. Or in India, there's extra floor given. So these are all different types of work that cities can encourage buildings to become greener and more resilient. We have programs to hire, to train EDGE experts, and EDGE experts are licensed by IFC, and they can work in all countries around the world. And these trainings are available online. We have done a large training in Turkey back in, I think, 2017, but we have these training ongoing globally. So that was our story on EDGE. There is quite a lot of videos online that you can look and see how it's been used in different sectors. But using that experience, what we came up with was to come up with a solution for resilience as well. The issue was that everyone was asking us, why don't you combine these two and make a building green and resilient in a single standard? But that was not possible. We wanted to make sure that the resilience has its own sister system to EDGE rather than having one system. So we came up with Building Resilience Index program. On the Building Resilience Index, the view that this is showing the global reported natural disasters. As you see, obviously earthquake is the one that is stayed the same almost, because obviously it doesn't have any relationship to climate change, but all the other elements are on the rise. And given the climate change condition, we are seeing that more flooding and more drought and more wildfires and more high winds. This is something that we are seeing it every day happening in a corner of the world continuously. And these disasters are very costly for economies, and some of the economies, they lose a good percentage of their GDPs to high disasters, mainly the island countries. And it's very important for us to come up with solutions. And obviously in Turkey, you have been experiencing earthquake, as we heard from Dr. Nazan. So this is important for us to figure out what can we do. And Turkey is one of the advanced countries in earthquake, but I think there is still room for us to improve our work. What we are doing on resilience has has 4 elements. There's wind, water, geoseismic, and fire. So the resilience would be based on these 4 elements from building point of view, and then each would have its subcategories of elements. I would say something else here, that this would be related to physical integrity of the building. So physical integrity of the building is to keep the structure sound, but also there are measures of operational continuity. And the operational continuity is also important to keep the buildings operate after the disaster. So those are the 2 elements together under these 4 verticals. Why this is important, and I guess this is important for everyone, but just one element that I like to highlight here is that we want to make sure financial institutions and banks understand the benefit and importance of resilience and come up with solutions, financial solutions to support this sector. And that's our focus area. When we look at most of the countries, we see that there are issues on data, as we saw that Turkey is developing the hazard maps, which is great. And these hazard maps needs to be keep on updated and relevant all the time. Know-how, there are some gaps, mainly in the inspection of the construction. We see that there are issues in inspection of the construction. Increasing awareness, financial institutions, policymakers, and in some countries, we see that bureaucracy can create a bottleneck to resilience. So what we came up with is a solution called Building Resilience Index. It has 3 key components. Number 1 is, how do we identify risk? How do we know, if I'm an architect building a building in a specific site, what are the risks in that site? And how my design can contribute to solve those problems. So number 1, to understand it. Number 2, to solve it. And number 3, which is important, is how are we going to disclose it? Because if it is not disclosed, regardless of how good you design or how bad you design, it's very difficult to come back and judge or compare projects. So on identification of the risk, we want to collaborate with different entities around the world to bring the hazard maps together, to use similar standards so that architects and engineers, they can access that data freely and easily. So that's one part. This is a work World Bank has done with the Philippines government in Philippines, and the hazard maps for Philippines are already released. The second piece is, now that we have that, how can we solve it? And that goes back to engineering solutions and what is the guidance for engineers to follow. Part of that is codes, national codes, but part of that also is global best practices. So how can we ensure that the national codes are fully implemented at design, construction, and supervision? And then what can we do to make sure they are also going beyond the codes to global best practices? And then measuring the cost of those elements so that we can communicate that. Some people, they feel that making a resilient building will cost twice, but in reality, it may cost 5% to 10%. So that's where we want to bring more transparency to the cost. The Building Resilience Index would have 5 levels. It will start from R, which is risky, and then it goes to A+, which is the best building that one can design, and everything in between. B, it is the code, national code level. So even a B rated building is a very good building. A is global best practices, and A+ is global best practice plus operational continuity measures. That's how these 5 levels is defined. We have right now 2 active projects, one in Philippines, one in Caribbean islands, because they are quite exposed to lots of natural disasters. We are also looking at expanding to Fiji and Pacific Islands, but the view is that this program will cover entire planet. So we're hoping that we can one day come back and have this solution for all countries, including Turkey. What brings this together, all these pieces together, is that IFCs work with direct investments, with the banks, with the governments, and also with certification solutions. So what we want to do is to build the ecosystem by connecting these pieces together so that then the market starts moving forward, given the players are all in place. I'd like to thank our donors. This program, the EDGE program, has been supported by the UK government. The UK government is supporting us to develop the program, as well as develop incentives through the banking sector. Also, the Swiss government has supported our program to grow so far, and we are in collaboration with Swiss government, plus other governments like European Union, Japan, and other governments that are supporting us in this program. On the resilience, the main supporter of the program has been the government of Netherlands. We are very thankful to Netherlands. And recently we started collaborating with Australian government, Department of Foreign Affairs and Trade, and obviously the World Bank Group. And we acknowledge our contribution from the organizations that supported our program for technical development of our program. Thank you so much, and I stop here and pass the ball back to Dr. Yakani and Dr. Jawad. Thank you so much.
Thank you very much, Dr. Omid Saberi, Washington-based international researcher. It was our proud to have you in our seminar. Yes, Dr. Yakani, if you want to add anything, if not, I will introduce our third speaker. Do you have my voice, Dr. Yakani?
Sorry.
Okay. Thank you very much again, Dr. Omid Saberi. I'm going to introduce our third speaker, Dr. Ali Asghari. He is Associate Professor in Disaster and Emergency Management from York University. Dr. Ali Asghari is an expert in disaster management. He is the author of many international articles and also winner of many international awards, such as International Association Board of Emergency Management. Yes, please, Dr. Al-Askhari, we will be glad to have you again in our seminar. Yes, please.
Thank you very much, and thank you all for being in the session. It's my pleasure to talk for the next 30 minutes on this topic that is a little bit different from previous presentation, although quite relevant and connected in my view, in a sense that we are all talking about disasters, disaster impacts, and also the importance of green and looking into sustainable and resilient building and structures, as well as communities and societies. So what I am basically trying to cover in my talk is a little bit discussion, more or less, about what is meant by building back better in the context of global pandemic. As you can imagine, this is even the recovery reconstruction, if we may say that, for COVID pandemic has not started yet. But before that, before reaching to that point, we need to start thinking and planning for that when it comes, which is not probably far, but at the same time, it is important to look into it. So there are basically some thoughts and ideas based on what is going on in the literature, in expert opinion, and etc. about this topic. So the real question, there are two basic questions here that we are often asked. I have been doing research and work in post-disaster recovery and reconstruction, and one question that comes to me and has come to the discussion among the profession in recent months has been around what really means build back better for pandemic. And it is because obviously we know that UN agencies and others have set this build back better as one of the primary setting and goals for post-disaster recovery reconstruction. So the question is natural in that context. You need to see whether this fits or not, and if it does, how. And the question is how we can make it if it is really an issue of consideration, or if this concept of build back better is relevant, and even if it is, it needs to change. So I'll start with giving you some background. I'm sure being in this area of work, maybe you already know some of these, but just to highlight some key aspects of build back better and where this comes from overall and where we are at in this terms and practice. Basically, after every disaster, whether it's a small or large, whether it's climate related or seismic related or human-based disasters, especially where there are lots of damages to physical world, you have three options or end up with outcomes. I say option because you may choose either of these intentionally, or even if you don't choose intentionally, that is what you may get after the post-disaster recovery and reconstruction. So either you build back worse, which means you are not doing much, basically, and nobody wants this kind of post-disaster recovery and reconstruction. But this has happened in the past, unfortunately, that some of post-disaster recovery reconstructions didn't end up doing good. In fact, they changed and created much more problems than before the situation. And you also have situations where you talk about build back the same, which obviously means creating almost or trying to achieve what you had before the disaster. This is what we can call it minimum expectation also, which is an expectation or a situation where people may be satisfied with, but it's not, of course, ideal. The concept and idea of Build Back Better basically comes from the idea that, now that disaster has happened, now that we have learned a lot from this situation, which is unfortunate, but let's use this as an opportunity for change, an opportunity for enhancement, an opportunity for making society, community more resilient and better. So that is very simple, obviously, but it is not that simple to achieve this. I mean, the whole, academic and practitioners work around this concept in the past since this started, and I'm talking about this in shortly, is trying to see how we can actually achieve this idea. Now, obviously, when it comes to disasters like what was discussed before, Build Back Better after major, for example, hurricanes, after major earthquakes, after tsunamis, after wildfires, makes quite relevant in terms of terminology when you talk about Build Back Better, because you have certainly lost a lot of physical structures, buildings, whether schools, hospitals, houses, roads, etc. But in the context of a pandemic, we really don't have these situations. There's no building damage, obviously. And the good thing is that as I'm speaking, everybody actually is now an expert being in this post or in pandemic situation. We all know about what's going on and what we are seeing, observing. There's not much really new, at least in terms of explaining the situation. But it helps contextually and conceptually to make this connection between and difference between this type of disaster and others when it comes to Build Back Better. Now, there's no obviously infrastructure damage. You may argue that there are, here and there you may see some direct or indirect relation, but it's not widespread, or you can not say this is real issue related to the pandemic. And there's no public facility damage like we have in other disasters, no damage to transportation systems. And indeed, you don't have much displacement. You may have some other aspect, which, for example, relates to quarantine issues, travel ban, etc., that has its own, characteristics. But in the sense that we experience in other disasters, for example, when the tsunami happened, you had large, significant number of people displaced because of the tsunami, and they had to be put into emergency shelter and temporary housing. It is not the case now. Most of us, we live in our home without problem. Even those who have been impacted by a pandemic, still they are in their homes if they are not in hospital. So the situation in terms of the physical damage is quite different. However, as we have experienced and we know, there are lots of obvious damage to economies. You know better than me now that this pandemic is now the world's largest in terms of economic damage, largest ever disaster, basically. It surpassed all other previous disasters that we know of in terms of financial cost. And still we are in the middle of the pandemic. We don't know exactly where this is going to end and how, but the cost is obviously increasing. And there are numbers that are now, it's hard to even imagine. It goes up to trillions dollars in terms of value, but again, it is rising. But we know also that there was significant damage to health system. When we say health damage, it's not real necessarily the physical damage, but damage to the system in terms of obvious reasons in terms of health and provision of health services, etc., and the people who are running these services, and damage to communities in terms of all different aspects, including social and mental issues. We have had experiences of, and we are still experiencing damage to trust between different sectors of the society and between governments and people, between people and agencies, etc. And obviously, there has been a lot of problem in terms of damage to overall social systems. So we have damages in different ways or meaning. Now, briefly speaking, when we talk about Build Back Better, although the literature goes far beyond this particular case, but more or less you can say, or at least people agree, that wider use of Build Back Better concept after disaster started with post-tsunami Asian, South Asian tsunami, where many countries were impacted by the tsunami, and Clinton was an ambassador for taking the recovery process of that region at the time. And as part of that process, they developed what is called the key propositions for Building Back Better. And so this concept came into mainstream discussions of disaster and emergency management from that time. Now, no need for me to go into details of that, but overall you can see that these 10 propositions really aiming to make sure that this post-disaster recovery and reconstruction is providing and using this opportunity or disaster as an opportunity to change in many, many different ways in terms of how governments actions or govern communities and societies, how coordination among different stakeholders are handled, and how we can make the recovery as a situation or as a process where if you go back and compare what you now have with what you had, you certainly feel that this is certainly a very better achievement and growth and development. So it is really about that. Now, subsequent to that, obviously, after this concept being used by this particular disaster and other disasters that happen in between, and as UN was also moving from the previous Hyogo framework of action from 2005 to Sendai framework for disaster risk reduction in 2015, this concept had reached to a level of maturity and global or wider use, so it became also part of the Sendai framework for action. Priority 4 of this framework is basically covering all about this building back or build back better. And in that, I mean, it is really hard to summarize what this priority talks about, but overall, based on a summary that our friend and colleague Ben Wisner has developed and expanded on that, you can briefly mention that this priority is talking about good governance or government for post-disaster recovery and reconstruction, and creating a sustainable and equitable economy, as well as having an ecology which is based on respecting the environment, helping the environment to sustain, and also human settlements that are resilient and comfortable for people to use, plus considering safety nets and essential services for the overall population, the whole population basically, and making sure that this post-disaster recovery and reconstruction is or pay attention to vulnerable groups of different types. So Build Back Better within this document, which is now official document all governments are trying to attach themselves to this is obviously a guideline for countries for the next also 10 or so years. And so the question of what this document talks about, Build Back Better, relevance to pandemic is obviously important. Although we know that even this document, when it was being prepared, and many experts behind that, I was in this conference or discussion when it was happening in Sunday, seeing people discussions, while there was some reference to some sort of health issues and pandemics, but really this was beyond this discussion. And had, for example, we experienced such a pandemic at the time, I would imagine that this priority for the same way we are looking at now wouldn't be the same, obviously. And things will probably change in the next framework if we even continue this discussion in terms of waiting for 2030 to change or make changes to this document. There, I believe, would be probably more changes with regard, because this pandemic has already impacted even the priority one of these by leaving us a large number of deaths that are way beyond the targets of this frame. Now, as I said, when we were talking about Build Back Better, at least in academia, what happened, this is very short, quick snapshot of what kind of or number of publications in Build Back Better. As you can see, there were very low numbers before 2005, and gradually as it became it's used in the tsunami case, and afterward, the attention started to rise, and much more, of course, after the Sendai Framework on Action, because this is now being implemented, and academics and others are trying to find ways to accommodate this into their research and practice. So you see sharp increase in this kind of research and activities as well. Now, in terms of how to operationalize or define this concept, I believe because the previous documents were not so clear in terms of measurements and operationalizing this, there have been some works to at least explain this measurement and also explain the benefits of this. One that is, there are two documents that I'm referring to from the World Bank, quite related to previous discussion, but in this Build Back Better concept, which is this document of named Unbreakable. Basically what it does, it defines Build Back Better into three main areas that now, even if we want to talk about post-pandemic situation, we can think about this and we can see if such an approach or model would work here, or if it does, how we can use it. But as you can see, building back better here means building back stronger, which more or less relates to physical construction or post-disaster recovery of infrastructures and buildings, etc. And obviously takes care of the fact that you want to make buildings and infrastructure the way that they can sustain future risk and hazards. And also building back faster. This is another, I think, new in a sense, in terms of operationalizing this, means that in post-disaster recovery construction, you also want to make it as fast as you can, because by making the recovery faster, you are already saving a lot and also providing what people have lost to them in a faster manner. And also build back more inclusively, which is not in a sense very similar to the previous two items, but more into social, human, aspect of this by involving people impacted by disaster into the post-disaster recovery and reconstruction. Now, my talk mostly when it comes to post-pandemic or pandemic recovery is whether and how these concepts can be applied, or even if they are relevant anymore. Another document that you may want to look into that helps in terms of understanding, and at least here in this one, also by World Bank, is that you can measure, in fact, those three items that I covered in the previous slide in terms of benefits if you try to implement each of those options. This map basically shows, for example, how much a country can reduce the losses if they build stronger. Meaning that the stronger you build, you will save more. And these are the countries based on, of course, their hazard context. The darker the color means that these countries would save much more if they basically create stronger post-disaster recovery and reconstruction. And in terms of, what they call it, reducing the loss, well-being loss. This is the same for the other one, which is benefits of building back faster, meaning that if you build faster, in fact, you will be providing more benefits to your people. And as you can see here, Turkey is highlighted in darker color, means that speeding up the recovery process would gain a lot more for the people. And again, this is some sort of valuation and putting values into these concepts just to highlight how important it is to make what's called this component of building back better. And this is the last part using the same document, which talks about inclusive recovery as part of this build back better concept. Here, as I say, it gives you the benefits or reduction in losses, well-being losses, if you bring in, facilitate and work with large number of participants, being more inclusive, gender-based, race-based, whatever you bring in under the umbrella of inclusive recovery of all kinds. Again, you see I don't want to go to details, but this is just to highlight the importance of, or the way at least this concept is operationalized. Now, there are obviously a lot of also academic discussions around this topic, which for part, at least you can see there is a significant relationship between what we call it build back better on the one hand, and two other discussions that was nicely presented by our previous speakers about resilient and sustainable development. We definitely want to make sure that our post-disaster recovery and reconstruction meets both concepts and bring them together and is aligned basically with them. But not all countries, not everybody, not what we see at least, not the assessment of what we see in terms of post-disaster recovery and reconstruction necessarily meets this, but you can see that relevance. In some places, and ideally, what you want is to have a build back better that is sustainable or goes toward the sustainable development goals. But for some, it's more or less about recovery surpluses, which means basically building back better in terms of all financial monetary values that you measure with, but this may not be necessarily sustainable. And finally, this is about...
Sorry to interrupt you, Dr. Askari. Only 5 minutes is remained. Sorry for that.
Thank you. Yes, I'm on track. Thank you.
Thank you. Thank you.
Now, as I said, there are also ways to bring in to measure this. There are lots of efforts that you can use to measure this kind of concept, one of which is listed here. Now, in the context of COVID-19 situation, the good thing is that we have already, the global community has already started thinking about this. I have seen, and you may also have seen, and at national level and other levels, discussions, documents, papers from different groups coming together to discuss this, because it is important. It is really a question that we need to answer right now. What kind of recovery and reconstruction we are talking about when it comes to COVID situation? And so we are building this capacity to at least understand the situation and hopefully plan something that helps us to go to a better recovery here. But I would also want to mention that there are lots of controversial discussions here, because first of all, not everybody really agree with the concept. So we may even not be able to use this concept in the context of pandemic unless we make some changes in the phrase or redefine it in some way. This is an example of that, which basically disagree with the concept in this context. Another idea that is also flourishing in terms of how this looks like, or we want to approach it, considering that it is not really physical damage, more of societal and economic damage to the whole society and the global economy, is to calling for new social contract and progressive policies. This is more kind of, if you would call it, radical view of the future or build back better in the context of pandemic. There's another thought related to that, which is more on institutional arrangement or institutional changes, which you may say is a middle ground where you may say build back better in that context may not be relevant, but there are lots of relevance in terms of need for renewing institutional or applying institutional changes. It's not radical, but it is like in the middle ground, as I said. But there are also new concepts emerging. For example, recovering better instead of using build back better, just to minimize the physical angle of it a little bit, or recovering better for sustainability. And this is very important. And I think the importance of this is that because there are some possibilities that we may actually, in post-disaster, post-pandemic recovery and reconstruction, if you call it, we may create a lot of sustainability problems, especially with regard to environment, because the whole globe is going to go to recovery. And if it is going to be fast, as we talked about in like previous disaster situations, it's going to create a lot of problem, which means we will have sudden pressure on the environment, which may not be sustainable, which not be what we want. But unfortunately, if this nationalistic view of recovery continues, we may actually face a sudden environmental disaster after or as we move into the post-pandemic situation. So some people are calling it resilient recovery, some people are calling it healthy recovery. Now, also you see this concept emerging into different sectors, and now you see papers, discussions around build back better after pandemic into food system, agriculture, transportation, tourism, all these different areas, which are interesting and of course important. I'm going to conclude with two other angles to this. This is one that you can also have, unfortunately, that is what I mentioned, which is, you can call it dirty recovery versus build back better, which may be a possibility, unfortunately, if we try to do this post-pandemic recovery in a way that is not environmentally friendly and sustainable. But I'm just cautious. I'm saying this is possibility and warn that this may happen, and hopefully this doesn't, but something to at least consider. And finally, this is also another aspect and way of looking at it is politicizing or political version of Build Back Better, which is obviously, you can now see that that concept has now gained attention into the world of politics, and the same word is now, or phrase is now used in politics. And now I wonder what would be the intermix of politics on Build Back Better and post-pandemic concept of Build Back Better, which are of course relevant in this, what happened in the US, but it is interesting to look at. Now, to summarize all these things, and I would say that we definitely need to build back better, but this is goes all the way into all elements of the society. It is much more comprehensive, or should be much more comprehensive, is more complex, it is long-term, and it should be thoughtful and planned globally together with every elements of the society. Otherwise, we will have probably we will experience a very bad post-pandemic recovery, and which may not be necessarily what we call it Build Back Better. And thank you very much. I was happy to meet and visit your city, your beautiful city in 2019. I had great experience in meeting, visiting all your different, architectural, entertainment, and museums in your city. I wish I can travel again to your place. It was the last travel I had before pandemic. Thank you very much for listening, and all the best.
Thank you very much, Dr. Askeri.
Thanks a lot, dear Dr. Askeri, for your great presentation. One of the interesting topics that today all the countries are trying to make some researches. I am going to introduce our last speaker, Yüksek Mimar, Mrs. Yasemin Sonuncu. She is a board member of SEBEP, Zero Energy and Passive House Association in Turkey, and also developer and coordinator of SmartGen. Her title will be on Zero Energy Buildings for a Healthy and Carbon Neutral Future. Yes, please.
Yes. Hello, good evening.
Hello.
And now it should be okay.
Okay.
Yes, it's okay.
Yes, okay.
Hello, and as the last speaker of this event, I would like to sum up the zero energy buildings for a healthy and carbon neutral future as much as possible. Actually, we live on the lands where people have been living for centuries, environmental friendly. They have been in harmony with the nature, and they have been using the renewable energy sources, in fact. When we go back all the way to 5th century before Christ, we see that Socrates has already designed his house in an environmental friendly way with a large southern facade and with a narrow northern facade, enabling the winter solar radiation in the house and preventing the excess winter prevailing winds to cool the house. And the large eaves on the south facade have been preventing the excess solar radiation at summertime to enter the building. And in those times, of course, there was no glass, so he has been using the shutters and the textiles as much as possible. And he has been also using the heat of the soil. And going even further back in the 5th century before Christ, at the Mediterranean Sea, people have been using the wind energy for sailing, for transportation and business. Coming to 1st century before Christ, Marcus Vitruvius Pollio, who was a very famous Roman writer, architect, and engineer, prepared his 10 books on architecture. And within these books, he has been discussing about the different buildings, the cities, how they should be located, how they should be preventing the excess wind, and how water is brought to the cities. In 19th century, after Christ, we see that ASHRAE has been standardizing most of the construction issues, and they have been issuing very many standards which are being used today in almost all the countries in the world. And actually, last month, they have been publishing the first review document for zero net energy and zero net carbon buildings. Coming to the green buildings, we see that there are an enormous amount of green building certifications in the world. Actually, it's quite difficult to compare these very different certifications. This was a study I made a few years ago. And it, in fact, took quite much time of mine in order to find a ground where we could really compare these different certification systems. And basically, the certification systems can be divided into two main groups, which are having a holistic approach with emphasis on environment, and which have a more specific approach on energy, and LEED, BREEAM, DGNB, and such systems are, such certifications are more within the holistic approach, whereas the passive house, Minergie, and F-Energy are specifically looking into energy issues. Even we divide these certifications into these main groups, we see that they have many different rating steps, and they have very many different categories. And the weights of these different categories are even different than each other. So after looking at all these certification systems, I would briefly like to give an explanation of zero energy buildings. The most basic and the most simple definition of zero energy building would be that these buildings require a very low amount of energy for their heating, cooling, ventilation, lighting, plug loads, and other consumption, and is fully are fully powered by renewable energy sources, either on site or off site. These zero energy buildings have four main principles. First, reducing the energy demand for all newly constructed buildings. The energy demand value is for the sum of the demands of the building: space heating, space cooling, domestic hot water, auxiliary energy, ventilation, lighting, and appliances. Secondly, improving indoor environmental quality, allowing maximum thermal comfort and avoiding overheating. This includes air quality control through mechanical ventilation. Thirdly, fixing a percentage of renewable energy demand to be covered by renewable energy annual balance. It is also important to amend additional measures to address energy matching and storage issues. Fourthly, reducing the overarching value for primary energy consumption and carbon emission per year. It is also important to amend additional measures to address mobility and materials embodied energy issues. Actually, when we are talking about zero energy buildings, it is very important to discuss the different phases which can lead to a zero energy building. When we look to the present culture and the present system which is being implemented, we see that the different stakeholders or the project phases and construction phases are working on a sequential manner. And when we look at this very simple, basic, generic workflow, we see that the building facilities are not included. And actually, when we are designing buildings, it takes between 2 months to up to 1 year to fulfill this phase. And according to the financial situation of the building owner, the constructions may take between 1 year to up to a few years. But when we are talking about the facilities of buildings, in normal buildings would last up to 60 years. And if we are talking about cultural heritage buildings, we are talking about buildings which would last a few hundred years. So in order to come up with zero energy buildings, it is important to include the stakeholders from the beginning of the design stage and come and go and have a circular working flow rather than a sequential working flow. I would like to discuss a bit about the key performance indicators and the thresholds for zero energy buildings at this slide. Despite the overall increase in zero energy buildings worldwide, constructing zero energy buildings face 3 fundamental challenges. The first challenge is mainly the performance gap between the gap which represents a significant performance difference between the design assumptions and the real building energy consumption. On the level of design, the energy performance gap is directly related to the lack of setting clear, measurable performance indicators and thresholds together with the use of theoretical simulation and calculations. On the level of construction, the performance gap is related mainly to the poor realization and lack of quality assurance. Finally, on the level of occupancy, the gap is related to occupant behavior, systems controls, and climate variations. The second challenge is associated with zero energy buildings is the sick building syndrome. There are many important aspects than energy performance, such as internal air quality, daylighting, occupant productivity, satisfaction, and thermal comfort that could be overlooked when designing zero energy buildings. Health problems, increased absenteeism, and comfort-related problems are very common in high-performance buildings. The third challenge is in zero energy building design is decision stress. Combining passive and active systems early on the stage is quite a challenge. The complexity of zero energy building and the major challenges regarding the performance robustness of zero energy buildings form a choice stress for many design teams, meaning making informed decisions. Using performance-based design approaches and setting clear and measurable performance goals and thresholds is the best methodology to design robust and performative zero energy buildings. By prioritizing the performance indicators and thresholds, decision makers can focus on closing the energy performance, achieving healthy zero energy buildings, and assess design scenarios to create more performative designs for zero energy buildings. Here, I would like to share with you a building energy specification table. This is actually a table we had created a few years ago for an academical building. And actually, we as designers, architects and engineers, we all agree on the numbers and targets on this table. And once we agree with the engineers on this table, as an architect, I can design a cylindrical building. I can design a pyramidal building. It can be a rectangular building. I can bury my building under the ground. I can build a skyscraper according to the wishes of the building owner, as long as I and the engineers, we all agree with the targets on this table. Here, I'd like to talk a bit more about the key performance indicators and the performance thresholds of the zero energy buildings. So the first performance threshold for the zero energy building would be the carbon emissions threshold. To meet the high performance target of these buildings, the European Union suggests that an overarching primary demand and carbon dioxide emissions threshold associated with energy demand should be below 3 kilogram carbon dioxide per square meter per year. The second threshold we would be looking in would be the minimum energy efficiency threshold. There are significant differences in the definition of minimum building energy efficiency threshold performance worldwide. The disparity is mainly due to the climatic, social, technological, and economic variation between countries. The third threshold is the heating and cooling balance. The necessity to solve potential conflicts between winter and summer comfort objectives indicates a higher probability of having to install both heating and cooling systems and to bear the associated costs. The next threshold is the indoor environmental quality limits, or in other terms, the thermal comfort. The available models worldwide are mainly focused on office buildings, partly because of the limited number of surveys in the area of residential buildings. However, the scope of these standards can be extended to other buildings of similar type used mainly for human occupancy, with mainly sedentary activities and dwellings. For zero energy buildings, short and long-term comfort indices should be calculated according to EN 16798, in addition to energy performance indexes. The connection between the thermal performance and comfort is explicitly discussed in EPBD. Also, various organizations have made proposals for comfort targets. The next threshold is the renewable energy generation threshold. For zero energy buildings, it is necessary to first reduce energy needs for heating and cooling. In the second step, to cover a significant portion of those needs by energy from renewable sources on-site or nearby. However, many new constructions worldwide fail to take up ultra energy efficient and renewable energy measures that are cost effective. The next threshold we look into is the occupancy density. Design teams should take into account the importance of occupancy density and need to design for diversity, allowing densities to be raised locally in buildings. The building capacity is a crucial design performance threshold because people create the demand for indoor environmental quality and building services. Post-occupancy evaluation studies should be encouraged to close the carbon and energy performance gap and achieve higher productivity and satisfaction of users in zero energy buildings. And the last threshold I would like to discuss is the cost threshold. In order to design and construct zero energy buildings, cost effectiveness is essential. Design teams should focus on cost modeling to come up with rough estimation of cost per square meter for zero energy building in different typologies early on in the design stage. The zero energy buildings have proven to be technically feasible, in some countries cost neutral, and in some countries costing 15 to 30% more compared to conventional buildings. In all typologies, buildings require high insulation levels, technical installation of HVAC and heat recovery systems, as well as more capital-intensive renewable energy sources like photovoltaics. By time as the market takes up for zero energy buildings, the investment cost will be reduced. Now I'd like to talk briefly about the internal environment quality in zero energy buildings. Designers are responsible for enabling and empowering user assess and measure the outcomes of their design in relation to the air quality, thermal, visual, and acoustic comfort. At the same time, zero energy buildings built today should last for at least 60 years and allow the adaptation and evolution of buildings use and the combination of professional and living activities while maintaining a high standard of internal environment quality. The first challenge that design teams should be aware of is the health compliance versus energy compliance. Finding a balance between zero energy building tightness and internal environment quality is not easy. Zero energy building tightness is associated with energy efficiency, while internal environment quality is associated with high energy consumption. Zero energy buildings are by default tight and should avoid leaking of envelopes and ductwork to achieve energy efficiency. The second challenge is to guide the decision-making in internal environmental quality design and provide exemplary assessment and control. There are many indicators and design targets to achieve internal environment quality. Integrating air quality and ventilation, thermal comfort, daylighting and views, acoustic comfort, interior design, and personal control are critical to successful internal environment quality. The third challenge is empowering and enabling occupants in relation to internal environment quality of their built environment. We build zero energy buildings for occupants and to support their well-being and productivity. Occupant control of their indoor environment is an essential factor in the overall satisfaction and energy balance. As we talk about internal air environment quality, of course, we cannot neglect to talk about the outdoor environment quality too. We are witnessing increasing urbanization around the world. Cities are increasing, concentrated to host more and more economic and social activities. Urbanization increases the risk of air and noise pollution and microclimate change, and therefore the negative impacts of extreme urban climate and pollution concentration are becoming more and more important. We need to understand the risk associated with the outdoor environment of zero energy buildings because people need air exchange for a healthy indoor environment. So the first risk I will talk about is the poor air quality. The World Health Organization, which monitors air pollution in all parts of the world, confirms that more than 80% of people living in urban areas are exposed to low air quality levels. As people spend 60–90% of their time indoors, they are exposed to illegal air pollution that can cause serious long-term problems. There is increasing evidence in the medical literature that air pollution is linked to heart disease, lung cancer, worsening asthma, and poor lung development in children, causing more than 100,000 deaths in Europe in 2016. Outdoor air pollutants are mainly nitrogen dioxide, sulfur dioxide, ozone, carbon monoxide, and particulate matter of various sizes. People who live near noisy roads or near airports may be at risk of high blood pressure. Noise also creates an unwanted distraction, causing a great dissatisfaction and productivity drop among building users. Extreme heat and cold episodes are becoming more frequent in the cities around the world. Since 2000, cities around the world have experienced prolonged high temperatures and humid hot summers for weeks. A recent report from the World Trade Organization and the United Nations Environmental Organization predicts a decrease for heating degree days and an increase for cooling degree days by 2040. Evidence from the literature shows that the frequency and severity of extreme weather events have increased significantly over the past 20 years and will continue to increase unless drastic measures are taken to reduce greenhouse gas emissions. As a result, energy regulators and companies have issued warnings that power grids in many countries will not be able to provide enough power to meet the demand from air conditioners during the heat waves. To cope with climate change and extreme weather events, zero energy buildings design can prepare buildings for such scenarios and risks that will arise more frequently in the future.
Mrs. Yasemin, sorry for interrupting. I just want to remember 5 minutes is left. Thank you.
Okay. The urban heat island effect is an important phenomenon of temperature difference between urban city centers and surrounding rural areas. The temperature difference is greater at night than during the day and is most noticeable when the wind is weak. The main reason for the urban heat island effect is the modification of land surfaces using predominantly concrete and asphalt in urban design. Cramped and deep street canyons can block and weaken the prevailing wind, resulting in reduced air dispersion capacity. The urban heat island has a significant impact on the comfort and energy consumption of buildings. The literature provides sufficient evidence that the main factors contributing to the urban heat island are large surface of low albedo and high absorption material, tall buildings in narrow streets, reduced vegetation, limited shade, and anthropogenic activities that produce heat. Urban heat island reduction policies, including green infrastructures, street vegetation, or green sidewalks, and green roofs can lower the average air temperature by 1 to 3 degrees Celsius on hot summer days. Therefore, it is important to take into account urban heat island effects and associated heat stress that may affect indoor air quality in zero-energy buildings. Quickly, if we go through the design and use stages risks, we can talk first about the climate characterization. Designers often use climate classification systems, indicators, or daily comfort deviation thresholds for human comfort to evaluate a particular climate. However, we are faced with climate change and massive urbanization, as well as microclimate changes around the world, which jeopardizes the accuracy of the classifications. Basic climate characterization should be based on new and climate-sensitive indicators and temperature thresholds that represent the true macroclimate of the project site. Two elements in zero-energy buildings can cause overheating. The first element is related to the weak shell and design of HVAC systems, while the second is related to the poor estimation of internal heat gains and user density. The evaluations of zero-energy buildings after commissioning show that building usage and occupancy density has changed, and users adapt the environments to the expected functional and hierarchical work order and methods over time. A procedural framework should be planned, designed, and followed during the construction and operation to ensure indoor quality. Verification and quality assurance of indoor air quality should be provided through energy management systems that monitor indoor air quality, thermal comfort, lighting, and acoustic environment. Source control and filtration maintenance protocols should be designed early in the process, and facility managers should be assigned. Since zero-energy buildings are airtight and well insulated, the build quality must be very high to prevent leakage, heat transfer, or deterioration of the HVAC system. I briefly explained the zero-energy buildings, and I also mentioned that every country have their own policies and their own construction culture. So it is very difficult, again, to come to a common targets and common understanding in zero-energy buildings. So every country would have their own targets. But I would like to very briefly give the basic principle of the passive houses. Passive house standards are actually a prototype for all, they are the same for all climates, for all countries. And they can be constructed anywhere in the world. So basically, the passive house has a high value heat protection all around the building. The opaque components like roof, external wall, and floor slab have U values of up to 0.15 watts square meter Kelvin. This corresponds to an insulation thickness of between 25 to 30 centimeters when standard insulation materials are used. The insulation and windows are installed without thermal bridges. The windows have a U value up to 0.8 watt square meter Kelvin. For this, insulated window frames and triple glazing are essential. The glazing has a high total solar energy transmission factor, G of 0.5 to 0.55 as a rule. The solar radiation contributes to the reduction of the space heating demand. The thermal building envelope is enclosed by one airtight envelope. This may be interior plaster, timber-based boards, or membranes. Airtightness must be tested using a pressurization test. At 50 Pascal, the air change should be 0.6 per hour. All rooms inside the thermal envelope are ventilated by a ventilation system with heat recovery. The heat recovery rate must be at least 75% so that efficiency as well as room comfort can be guaranteed. The total ventilation electricity demand should not exceed 0.45 watt-hour per cubic meter. Electrical appliances are designed as energy efficient. Large glazing areas on the south side and glazing towards the east and the west are fitted with the sun protection positioned on the outside so that in the summer the solar load can be minimized. Actually, if we are targeting to keep the global warming below 0.5 grades Celsius by 2050, we have to act now and we have to start immediately. And this was a very, very brief introduction to zero energy buildings and passive house standards. And if you are interested in learning more about it, between 22nd September and 26th September, we will have a 5 days of forum, and registration is free. Please join us. Thank you very much.
Thank you very much, dear Mrs. Yasemin Sumuncu, for your great presentation.
Thank you very much.
We want, Dr. Yukani, if you we want to come to ask and answer part.
Of course.
If anyone have any question from our speakers, can speak. The microphone can be on and speak. From our professors or students among us, if you have questions, yes, please. Okay, I can ask a question.
I do have a question.
Yes, please.
All right. So I think the question is, it may be to all the speakers over here. I didn't choose a specific speaker for this. But I do understand that we need to build resilient cities, resilient buildings. It has to be transformation, and the transformation has to happen immediately, now, basically, right? Thinking of Istanbul or or Izmir in Turkey, a city which is prone to earthquake, and that's going to happen, we know. The transformation has to happen immediately by transforming the buildings to a stage which is more earthquake resilient and also energy resilient, right? What is the main challenge here? Where do we hit the wall? Why we're not able to accelerate this change? What are your suggestions, dear madams and sirs? I'm also wondering this. Where should we start? What is the entity that we need to go to and knock on the door and say, hey guys, please start doing this because we need this. So what is it? Is it the financial problems, the banks that are not financing this change? Don't we have enough incentives to start this change? I am sure, I'm 100% sure we have the knowledge, we have the technology, but where do we, what are the hurdles? Why can't we just overcome these hurdles? Any thoughts, suggestions would be very helpful. Thank you.
Thank you, Barrett, for your question. Yes, please.
Please, Dr. Yasemin.
Actually, I would like to give a very brief description on this. Just before the seminar started, we were speaking among ourselves how you can transfer knowledge to society.
Exactly.
How can people understand, digest, and take this to their daily routine habits? This is the most important issue. And Dr. Asghari, at his last slide, showed the recent President of United States. Think about what was going on in the United States a few months ago, before the elections, and you see how one person can change everything, the whole motto. What we were facing a few months ago, and now what we are talking. So he has been a great influencer. I mean, we have to promote influencers in the world much more. There is enough money. I'm sure Dr. Saberi is going to talk about this much more. There is enough money in the world. The most important thing is how we can take this money sources to come to what we are looking as to the benefit of the society, to the world, to the nature, for the future, leaving no one behind. I think we have to stop maybe the generic greed of people, understand what power means, and look at other issues. So this was what I wanted to tell. Thank you.
Thank you. Other speakers, if you want to add anything. Dr. Asghari, Dr. Saberi, Dr. Klich, Nazan Klich. Or if you have any other question.
Maybe I can try to add some more points to what Dr. Yasmin mentioned. The question is a very important question, and the key barriers that we found in the system is that when you look at the system, it's always in the building sector is quite complex, right? You have a lot of players. You have, I remember in the school when our professors used to tell us, you need to be a good architect and solve the problem. Being a good architect is not all the, will not solve all the problems, because you can design something, but if nobody going to implement those designs, then it's not going to happen, right? So it's not just one piece of the puzzle that needs to be fixed. We need, and there's always the cycle of blame, right? We may blame the contractors may blame the banks may blame the others. So there's like a cycle of blame. So that's why one of the pieces that can be helpful is to try to influence different players in the marketplace. And one of the players that we have not touched much is the banking sector, because banks, they have the money. And if you go to get a mortgage, if you go to get a construction loan, and if they tell you that you need to get certified and show us that you're resilient, the chances of us saying, no, we wouldn't do this is much lower. So that's why we like to encourage banks. And in Turkey, we had good success with some of the banks like Yapı Kredi, with Odea Bank, but that needs to continue continue to flourish.
Thank you very much, Dr. Saberi, for answering the questions. Any other question? Okay, ladies and gentlemen, it was a great evening. Thanks everyone for joining. As the last speech, I want to ask Professor Dr. Önder to have the last speech for our speakers and also participants. Yes, please.
Yes. Thank you, Dr. Cevat. I think today we listened precious speakers. Dr. Nazan shared projects on earthquake hazards map on Turkey. It was very important for us, I think. Dr. Saberi figured out advancing net zero buildings and how can we scale it with the age. I will check it after this seminar. Dr. Ali Asghari talked about disaster and build back better, and Ms. Yasemin described, I think, key performance of zero energy buildings. All of them all of speakers are very precious for us. I wish all of you healthy and sustainable days. We will meet our next seminar. Thank you, all of you.
Thank you very much for your participation.
Thank you.
Thank you so much.
Thank you, everyone. Thanks for joining us. Have a good night. Thanks for, yes, Dr. Asghari, thank you. And thanks, everyone. Have a good day or good night, and take care in these days. Bye-bye.